It's time for another post-mortem. Another reason why you shouldn't take something that's been sitting for about 40 years and plug it into a wall. Today we have our point of failure from the 1959 Gibsonette. This is the Astron filter capacitor, the 2010. This one has no readable capacitance. However, it does have a readable short to ground on the 20 microfarad portion of this. As it shorted to ground, it had a nice distinct fire shoot out of here as it went down and took out the other capacitor with it. This ended the power supply, or the B plus portion of the circuit, and ended the working operation of the amplifier. So what we're going to do is we're going to cut this open and see what really happened inside. Let's take a look. This stuff looks pretty benign, and people would just assume that they would plug it into the wall. And what we're looking at, and in this case we're looking at multicam capacitors, but we see this metal sheet, and we have more than one metal sheet, and they're separated. They're separated by a dielectric, and then it'd be another metal sheet, and they wrap around very closely to each other. And as they are wrapped around close but cannot actually touch each other, they have a capacitance. Obviously we're looking at this, sliced open, right? As we go down, we can see the layers below the burning. Okay, and obviously over the years, these things, they dry out, they get damaged, things happen, and if these metal sheets, which sit extremely close to each other, right, wrapped around, if by any means they should ever short out, then terrible things happen and flames shoot out, as we see demonstrated here. There's no actual real sheet to work with here. It's all charred. You can see some metal bits if I go under where the fire happened. So rather than show you a demonstration of carbon and charcoal, I'll just show you what we're looking at. So at a time, these things, the goal to get the maximum amount of capacitance based on size and surface area was also a matter of how absolutely close you could get two layers of metal, one on top of the other, without touching, right? Without touching each other. And that's the whole premise behind this. So after 50, 60 years, things go bad, things dry out. You'll see there's no liquid, there's nothing in here. It's all dried out. It's all oozed out of this thing, leaked through the areas here where the wires are, and around back here where the wax cap was. So the electrolyte is already gone. So it's just dry paper. The slightest hole, the slightest imperfection, bookworm, whatever, gets through, whatever gets through here. And the second these two things touch an arc, there's a fire, because we're talking about a lot of voltage right here. One side's always going to be the ground on these filter caps, right? So you're going to have a ground, and then you're going to have a side that's coming right off the rectifier with an extremely high, extremely unfiltered but high DC voltage, right? So to give a better perspective, I've unwound a portion that wasn't burned, and you can see that this is wound up concentrically. To give an idea here, as I unwind it, you could see here is a metal sheet, right? And there is a thin piece of paper, and this is soaked with an electrolyte, right? And this is another sheet of that paper stuck onto this. And here is another metal sheet, right? These metal sheets sit really close together for a really long distance. If you unwind it, you can see that there's an incredible amount of surface area, but the whole point is that they never touch until, of course, they're dried out and they damage. And you look at the paper that I've removed, and you can see that it is old and dried out. There used to be an electrolyte on here, but as I open it, there's nothing in here. There's nothing left on this paper. And basically, by having these metal sheets in such close proximity, but such an extreme amount of surface area because of the fact that it's rolled up, you could achieve these unbelievable amount of capacitances. And that's how these things are made. But it's also the reason why, like I said, they should be replaced, especially when you could see what the condition is when looking inside one of these. So I wanted to be able to see that. Let's see, metal sheet number 1, paper with some dielectric or electrolytic agent or chemical sitting closely on it, paper number, the metal sheet number 2, and there you go, you have a capacitor. 2 metal plates as close as possible, which by design never touch each other. And there you have it. So just thought I would share this with everybody. I hope you found it interesting. Thanks for watching.